Yes, sir, start.
Okay, good. So, first of all, the Doppler log is that it is giving us a speed over ground. Primary function is to give speed over ground, but in certain conditions, it also provides speed through water. So, this can give us both. जब radar use करते हैं हम लोग, there is something called ground stabilization, sea stabilization in ARPA. During that time, we have to use speed over ground and speed through water for different purposes. Coastal navigation, ground stabilization, when we give the ARPA speed over ground. तो वहां पे Doppler log change करना होगा. In ground stabilization mode, we provide the speed input to the ARPA, which is SOG. When ARPA is being used for collision avoidance out at sea, in sea stabilization mode, we have to give the input to the ARPA. The speed should be speed through water. So, the Doppler log is named after the principle of Doppler shift effect, which was in fact discovered or studied by Mr. Doppler, who was another scientist. So उन्हीं साइंटिस्ट के नाम पे डॉपलर शिफ्ट इफेक्ट प्रिंसिपल कहा गया. बट व्हाट इज दिस प्रिंसिपल? व्हाट इज दिस डॉपलर शिफ्ट इफेक्ट? Ankit, you want to say something?
Negative,
Ankit?
sir.
Okay, negative. All right. So the नहीं माइक्रोफोन ऑन था तो मैंने सोचा कुछ बोलना चाह रहे हैं. No issues. So what is this Doppler shift effect? Doppler shift effect is an apparent change of frequency received by the observer. अगर मैं सुन रहा हूं, जैसे मैं बोल रहा हूं तो आप सुन रहे हैं, तो I am the source of the sound, you are listening, you are the observer. So you can recognize my voice because you are sitting, myself sitting at the same place, no relative motion between us. But if there is a relative motion between source and observer, there will be an apparent change of the frequency received. The observer is going to hear the sound which is not the same. The sound will change. The frequency will either increase or decrease depending on the relative motion. If two people are standing, one speaking, the other listening, if the distance is same, whatever is produced is the same received.
So then
But
log
if there
speed
is
is
a
not accurate.
Come again?
Then log speed is not actually the accurate speed. The
Yes.
speed which we get from log.
To quite an
It is
extent,
not
it is
as
accurate. It is very good.
Okay, sir.
GPS also gives you speed over ground, and that also uses Doppler shift effect.
Okay, sir.
Okay. So first of all, the understanding of the principle. Principle says that there is an apparent change in the frequency received when there is a relative motion between source and observer. If the two of them are stationary and one speaking, the receiving party receives the same. जो ट्रांसमिट किया वही रिसीव किया. If the Ankit Thakur, please mute your microphone. मुझको बार बार लग रहा है कि आप कुछ बोलना चाह रहे हैं. Ankit, are you there listening?
सर 2 अंकित है सर, मैं अंकित आहूजा हूँ, दूसरे
नहीं
वाला
आहूजा नहीं, अंकित टी, अंकित ठाकुर, ठाकुर है शायद मेरे ख्याल से. टी पर ठाकुर.
तोमर है सर, वो अंकित तोमर है.
अच्छा तोमर, अंकित तोमर. हाँ हो गया, बंद कर दिया. अच्छा इसीलिए नहीं जवाब दे रहा था, ठाकुर मैंने बोल दिया. All right. So the frequency will change if there is relative motion. What is relative motion? Either the source is going towards the observer, or the observer is going towards the source, or both are going towards each other, or it can be other way around. Either the source is getting away, observer is getting away, or both are getting away from each other. If the distance between them is changing, there is a relative motion. What are we talking about? Example can be understood. You are standing on the platform, railway platform. There is a train coming. As the train is coming close to you, passing, coming at it from a distance, it is also blowing horn. आप जब स्टेशन पे खड़े हैं, ट्रेन आ रही है, हॉर्न बज रहा है, what do you hear? Like that. आपने टीवी में रेस देखा होगा, बाइक रेस, कार रेस. Camera is stationary, trying to record the vehicles passing by. The camera is recording the same recording you are listening. So what the camera is hearing? The microphone. Like that. So the sound is constantly changing when the vehicle is coming and passing away. There is a marked difference between the two. When the train was coming close, the frequency seems to go different, and when it is going away, the change is little different. In what way different? The frequency seems to rise when coming closer. The frequency seems to go down when getting away. So, what is this frequency change? What is the difference between high frequency and low frequency? Suppose I am speaking, you are listening to a sound. I will be making an
amplitude.
No, not amplitude. Amplitude is this. I'm speaking to you. My amplitude, my voice amplitude is going to be less now. I'm speaking to you at the same voice, same frequency. Amplitude is more now. What was the difference that you heard? Same sound, loud and not loud. Is that correct?
Yes, sir.
Yes, sir.
This was the same frequency, amplitude different. More displacement, more vibration of the ear. Amplitude is changing. Frequency is, when I'm speaking to you, I'm making three sounds, three different sounds. Okay, I will give you an example other way around. You are listening to this, three sounds. This is one frequency. This is another frequency. This is another frequency. This is low frequency. This is high frequency. So, number of cycles per second is the frequency. When the vibration is fast,
Yes, sir.
frequency is more. When the frequency is number of cycles is less, frequency is low. In the orchestra that you listen to, there is drum beat, boom, 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 that kind of sound. And there is this guitar, sharp, violin. So what are the difference between the two frequencies? The bass, what we call.
Yes, sir. Bass.
The bass, what we call is the low frequency. इको साउंडर में हमने पढ़ा था थोड़ा सा पहले. Higher frequency is the sharper voice. So the frequency is changing when the observer is here. He is listening to the sound. Watch this out. The frequency is changing. ऊपर जा रहा है, and when the train is getting away, the sound goes like so the frequency goes down. Supposing there was no relative motion, the frequency change will be how much?
No change.
No change. अगर रिलेटिव मोशन थोड़ा थोड़ा होगा तो फ्रीक्वेंसी चेंज थोड़ा थोड़ा, अगर रिलेटिव मोशन बहुत ज्यादा होगा then more change. So now here we have said that frequency shift is dependent on the relative motion. जितना relative motion उतना frequency change. Now suppose I have the capability of reading the transmitted frequency and the reading of received frequency. If I can measure them both and if I find out the difference, can I relate it to the speed?
Yes, sir. Change in frequency. Speed.
अगर frequency change नहीं हुई, transmitted received is same, relative motion 0. अगर दोनों के बीच में थोड़ा थोड़ा change, then थोड़ा थोड़ा relative motion. अगर दोनों के बीच में ज्यादा change, तो ज्यादा relative motion. So this is what is used in the Doppler log. We transmit a frequency, we know what we are transmitting. When the signal which is transmitted, it is transmitted towards the seabed. When the reflected energy, reflected sound waves coming back, then I also read the frequency की जो आ रही है frequency वो कितनी. If there is a difference, there is some velocity. If not, then no velocity. So in the case of the ship, the source of the sound waves or acoustic wave, and also the recipient, the receiver, both are the ships only. The ship transmits, the ship receives. तो रिलेटिव मोशन कैसे होगा जब वहीं पे जहाज है? रिलेटिव मोशन इज इम्प्लाइड बाय द सीबेड. कैसे? तो understand this by another example. I have got a ball, rubber ball. I am throwing it onto the wall. When I throw, the wall is there. The ball hits the wall and it is coming back. By the time I am moving towards the wall. So when I threw the ball, the distance of the wall was so much. When I catch it, the distance has changed because I was continuously walking. So with respect to the wall, between transmission and reception, the distance has changed. Is that correct or not?
Yes, sir.
So relative motion implied. मतलब वहां से सोर्स मेरे लिए दीवार हो गई है, अब वहां से टकरा के वापस आ रही है तो वहां सोर्स है. और जब मैं रिसीव करता हूं तो वॉल के नजदीक में जा रहा हूं तो रिलेटिव मोशन है सोर्स एंड ऑब्जर्वर के बीच में. बट यहाँ तो सी बेड नीचे है, अब जहाज के नीचे थोड़ी जा रही है. सो वी विल सी दिस ऑन द बोर्ड हाउ द रिलेटिव मोशन इज अप्लाइड और implied in case of the ship. Let us go to the board. Okay, the board visible? Is the board visible?
Yes, sir.
Okay. So what happens in case of the ship? The ship is fitted with a device called transducer. Transducer's function is to convert electrical signal into sound waves and sound waves back into electrical signal. So during this transmission and during this reception, converting electrical signal into sound waves, sound wave into electrical signal. तो इस ट्रांसड्यूसर का काम यही है. The signal is transmitted at an angle alpha. It is not vertically transmitted, vertically downwards नहीं, क्योंकि तब relative motion नहीं मिलेगा. The shape is moving in this direction at the speed of v, whatever the speed. The transmission takes place. There is seabed. The reflection takes place from here. By the time the received signal is coming, the ship has gone little forward and the transducer is somewhere here. The ship has gone forward, the transducer is here. So is there difference between the two distances?
Yes, sir.
That means we can find out this is the relative motion towards which, by which the transducer is actually reaching towards the seabed. Actually, it is going in this direction, but this can be resolved in two components, towards the seabed and perpendicular to that. So if this is V in this direction towards the seabed, this V vector can be resolved in two components. One in the direction of the seabed, other perpendicular to it. And we already have the angle between this. So in this triangle A, B, and C, what is this relative motion? If the transducer is moving here at V, there is the apparent motion of the transducer towards the seabed. For example, what we are saying, if I am moving towards you, I am coming towards you, right? Because I am walking towards you. But if I am going in this direction, not towards you, I am going here. Have I come close to you or not?
Yes, sir.
I am going not towards you, I am going here. So have I come closer to you or not?
Yes, sir.
So if I
Yes,
was
sir.
moving at v speed here, I am coming towards you, one component and perpendicular component this side also. So a vector can be divided into two components which are perpendicular to each other. So if the transducer with the shape was moving in this direction at the speed of v, then what is AC here? What is AC? AC का वैल्यू
V sin alpha.
नेगेटिव v sin अल्फा नहीं, ये हो गया हाइपोटेन्यूज, ये हो गया परपेंडिकुलर, ये हो गया बेस. तो बेस और हाइपोटेन्यूज के बीच में रिलेशन
Cos.
यस कॉस.
Cos.
So in this condition what we are saying that when the ship is going here at v, there is a relative motion which is v cos alpha. Oh, there is a relative motion v cos alpha, and this relative motion is going to cause difference between ft, which is the transmitted frequency, and fr. जितना ये ज्यादा होगा उतना स्पीड ज्यादा होगा. अगर ये कम होगी तो रिलेटिव मोशन कम होगा. अगर शिप का स्पीड ज्यादा होगा तो ये भी ज्यादा होगा और भी ज्यादा होगा. So this is how the relative motion is implied. Now, one more thing, we said that there is a relative motion, then there is change in the frequency, apparent change in the frequency. What is the meaning of apparent? It appears to be so, it is not. ट्रांसमिट वही हुई थी जो हुई थी, मैं जो रिसीव करता हूं मुझको लगता है कि चेंज हुआ. So if there is FR, which is the received frequency, if FT is the transmitted frequency, then the difference between the two will depend on two other factors. एक तो हमने देखा था क्या कि relative motion, it will depend on the relative motion V, and second thing, it will also depend on wave speed, which is denoted by C. So this FR will depend finally on FT, V, and C. How are they related? In the classical physics, the Doppler shift equation is FR is equal to FT into C plus V by C minus V. This is the value of the FR. Supposing there is a car which is moving at the speed of 50 meters per second, and there is you standing here, and the distance between this and this, let us say, is 330 meters per second, 330 meters, and it is blowing horn. When it is blowing horn, the transmission is happening at 1000 hertz. The frequency FT is 1000 hertz, which is the sound which is traveling in the air at the speed of 330 meters per second. This is the sound speed in air. The speed at which the car is moving towards you is 50 meters per second. That means it is this. C is this. Tell me what kind of frequency you are going to receive. What frequency are you going to receive?
One 1357 hertz.
1357. So you see, it is increasing. Supposing the car was going in opposite direction, same speed but opposite direction. So क्या होगा? This will become minus V. This also will become minus V. नजदीक जाता हुआ पॉजिटिव, तो दूर जाता हुआ नेगेटिव. So that also please verify what is the frequency you are going to listen. थाउजेंड तो ट्रांसमिट हो रहा है.
$848.
Negative
736.
736 is correct. 840, no. Please verify once again. Confirm that. Please check your mistake that you are making. Somewhere calculation में हुआ है गड़बड़ कुछ.
736.8 होगा.
Yes, very good. So now we understand that if there is a relative motion between source and observer, the frequency received can go up or can go down depending on whether they are coming close or getting away from each other.
और ये सर ये समझाना सर ये वेव स्पीड जो आई सर ये शिप के मामले में कैसे लिया सर?
Relative motion.
ये सर वो जो वेव स्पीड है ना सी वो.
हाँ. Okay.
सर वो
So हमने साउंड वेव्स की बात करी. Sound wave requires medium to travel. That is correct. Requires medium. The speed will depend on the density of the medium. If the medium is more dense, the speed is also more. If the density is less of the medium through which it is traveling, then the speed also will be less. So in space, do we have any atmosphere? Do we have any medium particles?
No, sir.
No. So in the space, I keep talking to you. You see my mouth doing like this, but you are not going to listen because when I'm speaking, my vocal cord is vibrating. This vibration is pushing the air like this, and this air fluctuates and travels at the speed of 330 meter per second in air. Air की density जो भी है, given the temperature and pressure and humidity, it is traveling at 330 meter per second. The same vibration strikes your eardrum vibrates, the signal is converted into electrical signal that goes into your brains as an electrical signal. The brain processes this electrical signal, matches with previous records. अच्छा, सिन्हा सर बात कर रहे हैं, ये उनकी आवाज है. आंख बंद करके भी आप पहचान सकते हैं क्योंकि आपके हार्ड डिस्क में रेफरेंस पड़ा हुआ है. जब आप सुनते हैं तो उससे मैच करते हैं कि उसे कि हाँ मैं जानता हूं इनको, ये प्रसून सिन्हा सर बात कर रहे हैं. So basically biology is also physics. You have a sensor which converts the electrical signal, gives to the processor processes it and makes sense of it. The same principle used in the device. Now we said that it depends on the density. So air, normal case, normally 330 meter per second. Somewhere you will find 340, somewhere 333 meter. All are correct, depending on different temperature and pressure. In salt water, where salinity is 3.4% and temperature is 16 degrees centigrade, the same sound waves are traveling at 1505 meter per second. Salt water, more denser than air, speed is this. Fresh water, something like 1430 meter per second. So this is what the value we are going to use, but the accepted value is 1500 meter per second. The C, value of C, the sound speed, is taken to be 1500 meter per second for all calculations in Doppler log as well as in echo sounder. So हमारा c का वैल्यू निकल गया, करेक्ट? आर वी ओके विद दिस?
Yes, sir.
Yes,
सर
sir.
नॉर्मली सैलिनिटी ज्यादा होगी सर, तो डेंसिटी ज्यादा है तो स्पीड कम होनी चाहिए ना सर नॉर्मली।
बढ़ जाएगा, बढ़ जाएगा। एयर लाइटर है, सॉल्ट वाटर डेंसर है ना, तो यहाँ कम थी, ज्यादा हुई, और सैलिनिटी बढ़ाएंगे तो और बढ़ेगा, है ना?
नहीं सर, वो फ्रेश वाटर आपने लिखा और सॉल्ट वाटर लिखा है, तो सैलिनिटी ज्यादा होगी, डेंसिटी।
फ्रेश वाटर में डेंसिटी कम हो गई तो स्पीड कम हो गया ना, सैलिनिटी कम हो गई।
यस सर।
तो अगर आप हार्ड वाटर लेते हैं, जैसे ब्लैक सी, सॉरी डेड सी में है, वहां सैलिनिटी इससे ज्यादा है, तो वहां पे स्पीड बढ़ जाएगी इससे ज्यादा, ठीक है ना?
अच्छा, स्पीड बढ़ जाएगी, ठीक है सर।
यस। सो सी का काम हमने कर लिया, वी अंडरस्टूड सी। You asked me कि how it is being done in the ship. The ship Doppler log is having a transducer fitted at the bottom. आपके जो ब्रिज में जो डॉपलर लॉग लगा हुआ, उससे सिग्नल आती है, इसको प्रोसेसर से इलेक्ट्रिकल सिग्नल आता है, समथिंग लाइक 150 किलोहर्ट्ज. The signal is given to the transducer. The transducer is so designed that it will transmit the signal at an angle towards the seabed. The signal strikes the seabed and it is reflected back. So FT, what we are saying is 150 kilohertz. But the ship was actually moving at the speed of v. As the signal is coming from here, the ship is already moving. So there is relative motion between the two or not? The source was from here, reflection is happening from here, but the ship is moving. So by the time it is received here, the ship has gone forward. थोड़ा सा आगे निकल गया है जहाज. So what we said, that there is a difference between the two distances or not? Transducer was here, now it is here. So the distance between AB and BC has changed or not?
Yes, sir.
तो दोनों के बीच में डिस्टेंस चेंज हो गया, तो रिलेटिव मोशन है या नहीं ट्रांसड्यूसर और सीबेड के बीच में?
Yes, sir.
किसी ने पूछा था कि रिलेटिव मोशन कैसे था? प्लीज कंफर्म यू हैव अंडरस्टूड व्हाट वी आर सेइंग. किसी ने पूछा था मेरे से? अब जवाब नहीं दे रहे, ऐसे कैसे चलेगा? So here is this V. So V can be broken down into two components. If this is V, इसको हम V यहाँ पे दिखाते हैं. Any vector can be broken down into two components. So if this is V, it can be broken down in these two components. It can be broken down in these two components. It can be broken down in this component. So this V can be done like this. अगर ये है तो इसको दो कंपोनेंट में करेंगे, तो एक कंपोनेंट ये, एक कंपोनेंट ये, जैसे होता है ना, सॉरी, कि एक वेक्टर इधर को है, एक वेक्टर इधर को है, तो रिजल्टेंट क्या हो गया? ये रिजल्टेंट हुई या नहीं? है ना?
Yes, sir.
तो इस रिजल्टेंट को मैंने इसमें भी तो कन्वर्ट कर दे सकता हूं. मेरे पास एक ही वेक्टर है, तो इसको मैं इस दो कंपोनेंट में डिवाइड कर सकता हूं कि नहीं?
Yes,
दो
sir.
वेक्टर को एक में कन्वर्ट करता हूं, एक को दो में स्प्लिट भी तो कर सकता हूं. सेम थिंग, v यहाँ पे है, तो आई कैन स्प्लिट इट इनटू दिस टू कंपोनेंट्स. सो यहाँ पे अगर हम देखें तो इसको दो कंपोनेंट हम लेते हैं, एक कंपोनेंट ये हो गया, दूसरा कंपोनेंट ये हो गया, इसका काम नहीं है। So this V can be resolved in this component, which is V cos alpha. Please verify your understanding here. सब ठीक ठाक है अभी तक?
सर ये जो अकूस्टिक वेव जो निकलती हैं सर, वो मान लीजिए सर कहीं जगह सीबेड 700 मीटर पे होगा, कहीं जगह सीबेड 10,000 मीटर पे होगा, तो सर वो डिफरेंस नहीं होगा?
होएगा नहीं, डिस्टेंस से मैटर नहीं करता। अगर यहाँ पे है तो भी वहीं से आएगा। फ्रीक्वेंसी शिफ्ट तो हो रही है, ये तो अपनी जगह फिक्स्ड है ना, चाहे यहाँ पे हो, चाहे यहाँ पे हो, चाहे यहाँ पे हो, ये तो अपनी जगह फिक्स्ड है।
नहीं सर, बट डीप सी में बोलते हैं कि वो लेयर से वापस आ जाए, इको कम्स बैक फ्रॉम द लेयर, इट टेक्स इको फ्रॉम द लेयर।
वो ये प्रोसेस है कि जो हमने इलेक्ट्रिकल सिग्नल दिया, वो ट्रैवल की यहाँ पे आते आते वो मर जाता है। जो सिग्नल इतने डीप से मिलती नहीं, तो स्पीड ओवर ग्राउंड कहाँ से मिलेगा? बट आउट एट सी, इन द मिडल ऑफ द सी, आर वी मोर इंटरेस्टेड इन स्पीड थ्रू वाटर और स्पीड ओवर ग्राउंड? कोलिजन होगा, तो वहां ईएम लॉग मिलता है मुझको। This is required in which place? Coastal navigation, speed over ground. वहां पे डेप्थ कितना होगा? 60 मीटर, 50 मीटर, 70 मीटर, 30 मीटर, 40 मीटर, ऐसे में होएगा, काम करेगा बढ़िया। So no love lost, things are okay. EM log not giving us speed over ground, no problem. I don't want it because I'm in coastal water. I don't need speed through water. मुझको चाहिए Doppler log, वो देता है यहाँ पे। Out at sea, this cannot give me speed over ground. I don't require. I want speed through water. EM log देता है, so no problem. Both are doing good functions for both the places. जो वहां पे चाहिए वो मिलती है, जो वहां पे चाहिए वो मिलती है। दूसरा चीज दोनों नहीं करते, नहीं करते मत करें। अच्छा, आर वी गुड?
तो सर ये जो ट्रांसड्यूसर पावर जनरेट करता है अकूस्टिक वेव, तो सर वो डीप सी तक चले जाती है, लाइक इको साउंडर पे तो नहीं जा पाती, तो ये इसकी चली जाती है?
इसीलिए 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 आईएमओ परफॉर्मेंस रिक्वायरमेंट है कि 200 मीटर तक काम करना चाहिए। It should work for at least 200 meters, both for Doppler log and echo sounder. Both should be working good for these two depths. Doppler log should give me speed over ground till the depth of 200 meters. उसके बाद नहीं देता कोई प्रॉब्लम नहीं। Echo sounder should give me depth proper at least 200 meters. उसके बाद नहीं देता डेप्थ, कोई दिक्कत नहीं। अगर 200 मीटर तक दे दिया तो अब जहाज इसके बाद ग्राउंड होगी क्या? 200 मीटर से 250 मीटर हो गया, तो is the UKC a concern for me right now? 250 मीटर पे, so no problem. नहीं देता है तो नहीं देता है, लिमिटेशन है, तो लिमिटेशन को एक्सेप्ट किया हमने। आईएमओ परफॉर्मेंस स्टैंडर्ड में दोनों के लिए, एसडीएमई और इको साउंडर दोनों के लिए लिमिट इज, मिनिमम लिमिट इज कि 200 मीटर तक तो काम करना चाहिए दोनों, उसके बाद नहीं करता है, नो इश्यूज।
क्योंकि सर मैं इसलिए पूछा था, हमारे शिप में खाली सर डॉपलर लॉक था, ईएम लॉक था ही नहीं, तो वो कैसे बता रहा था डीप सी में भी?
डीप सी में स्पीड थ्रू वाटर आपको मिल रहा है। होता क्या है,
यस सर,
हम लोग जंप कर गए पहले, ये टॉपिक बाद में आती, बट when the signals are being transmitted from here, the depth is too much, तो जो यहां से रिफ्लेक्शन आ रही है वो जाते जाते मर गई, यहाँ पे डेड हो गया। अब कुछ एफआर में कुछ मिल नहीं रहा, इधर से तो जा रही है, आते हुए खत्म हो गई। तो होता क्या है कि देयर इज अ लेयर ऑफ वाटर somewhere here which is some 10 to 30 meters. हाँ, यहाँ से 10 to 30 meters का डेप्थ है. यहाँ पे एक लेयर बनता है जो अलग टेम्परेचर का होता है. आपने तो देखा होगा सी टेम्परेचर इंजन रूम से मिलता है हम लोगों को, तो कभी 24 डिग्री, कभी 22 डिग्री, कभी 18 डिग्री, अलग अलग मिलता है यहाँ पे. और जहाज का प्रोपेलर यहाँ पे, सेंसर यहाँ पे होगा, बट यहाँ पे भीतर ठंडा होता है. एट अ डिस्टेंस depth more than 30 meters, there is a different kind of layer. So some part of energy is reflected back from there. So this layer is the reflecting surface. यहाँ से weak signal आता है. This is weak. But some reflection takes place. But at the same time, there may be currents. जहाज तो चल रही है, लेकिन हो सकता है कि ये लेयर भी मूव कर रहा हो. So now are we reading our speed, relative motion happening with the moving water? Is that correct? So this is speed through water. It is not taken from the ground. It is taken from the layer of water, which is somewhere between 10 to 30 meters below the surface.
ओके सर.
Copy it? सही बात है.
यस सर.
तो Doppler log can give, हमने शुरुआत में ही बात करी कि it can give, mostly it is made for speed over ground, but in certain conditions it gives speed through water also. What is that condition? When the depth is more than 200 meters. जब भी ये डेप्थ बढ़ेगी, यहां से सिग्नल मिलना बंद होगा, तो ऑटोमेटिकली ये स्विच हो जाएगा STW मोड में, और व्हाट वी कॉल द वाटर ट्रैक मोड. इफ द सिग्नल बीइंग रिसीव्ड फ्रॉम हियर, बॉटम ट्रैक. इफ इट इज बीइंग वर्कड विद द वाटर लेयर, वाटर ट्रैक. STW is water track. Are we good?
यस सर.
सर एक चीज और क्लियर करनी है इसमें. सर ये स्पीड जो जा रही है नीचे पानी में, वो v cos अल्फा है, और जो रिसीव हो रही है वो c है, करेक्ट है?
Negative. Ship is moving at the speed of v. जहाज चल रही है, यहाँ कतार से चल रही है, और ये जा रही है गैल्वेस्टन को. तो ship is moving on the map on the earth at the speed of v. She is going from one place to the other. Move कर रही है ना? चल रही है ना?
चल रही है.
That is v. किस स्पीड से चल रही है? v स्पीड से चल रही है. 14 नॉट, 15 नॉट, 20 नॉट, 18 नॉट. That is the speed of that. But when the transducer is transmitting a signal, let us say 150 kilohertz, this signal is traveling through the water at the speed of c, which is 1500 meter per second. It goes at the same speed. It also comes back at the same 1500 meter per second. But what we transmitted, the frequency here was ft. When it is being received, it is fr. ये change हो गया. मतलब क्या कि ट्रांसमिट किया, पिंग, रिसीव हुआ, पिंग 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 पिंग, चेंज होकर फ्रीक्वेंसी मिल रही है मुझको. अंडरस्टूड?
यस सर.
Please clarify once again. Have you understood? The sound which is transmitted is traveling at so and so. The frequency is this, ping. The reflected energy which is coming is again also traveling at the same speed of c, but the frequency has changed. Ping, पिंग पिंग पिंग, दोनों साउंड में, दोनों पिंग में अलग अलग फर्क है या नहीं?
फर्क
यस
है
सर।
That is the difference between the frequency. Sounds are changing.
तो सर स्पीड सेम ही रहेगी, इसकी स्पीड कम नहीं
ये
होगी।
तो भाई, वो तो इकोस्टिक वेव है। इकोस्टिक वेव मीडियम में, सॉल्ट वाटर में ट्रैवल कर रहा है, विच इज फिक्स्ड। ठीक है,
राइट सर।
ऑल राइट। सो we have seen the basic equation. Fr will be dependent on Ft and C and V. Fr is dependent on these three things. But when the ship was transmitting the signal at an angle alpha, the relative motion which is causing the frequency shift is V cos alpha. Is that correct or not? This is the relative motion. Correct?
यस सर।
That means यहाँ पे V की वैल्यू क्या होनी चाहिए इस केस में, डॉपलर लॉ के केस में?
V cos अल्फा।
Exactly. तो हम लोग शॉर्ट में देखेंगे how we can calculate the value of V. How do we find out the value of V from V cos alpha? The alpha, Ft which is being transmitted, Fr which is being received. So using this formula, Fr is equal to Ft into C plus V by C minus V, we can also say in this Doppler log case, Ft into C plus V cos alpha by C minus V cos alpha. Then we divide it by C in order to derive the formula. हम इसको और इसको दोनों को C से डिवाइड कर रहे हैं, तो we have Fr is equal to Ft into C by C is equal to 1, then V cos alpha plus V cos alpha by C divided again, इसको भी हमने C से डिवाइड किया, इसको भी किया, इसको भी, इसको भी, तो we have 1 minus V cos alpha by C. Is that okay or not?
यस सर।
So here we see, can we write this in this manner? हम इस तरीके से लिख सकते हैं कि नहीं इसको?
यस।
Watch this out. Is it looking like 1 by 1 minus x? अगर इसको हम x मान लें तो 1 by 1 minus x. Is it like this?
यस सर।
This is binomial expression where 1 by 1 minus x. We know 1 by 1 minus x is equal to 1 plus x square plus x cube and so on, x to the power n. So we replace this value. Now x is what? X is what?
V cos अल्फा by C।
V cos alpha by C. जहाज का स्पीड कितना होगा? बहुत होगा तो 20 नॉट होगा. Cos alpha normally 60 degrees by C 1500 मीटर. अगर स्क्वायर करें हम तो 20 स्क्वायर by cos स्क्वायर 60 by C स्क्वायर 60, तो ये 400 हो गया और ये कितना हो गया? What will be the value of this? वो छोटा सा हो जाएगा या नहीं?
यस सर।
तो हम हायर पार्ट्स को नेग्लेक्ट कर देते हैं और यहाँ पे जो हमने 1 by 1 minus x की जगह 1 प्लस एक्स करते हैं और एक्स ऊपर की वैल्यूज को छोड़ देते हैं. हायर पावर्स ऑफ सी विल लीव. So we have Fr is equal to Ft into 1 plus E cos alpha by C. This one into 1 plus x we are neglecting higher powers of C. So we have 1 plus B cos alpha by C into 1 plus B cos alpha by C. A plus B, A plus B, A plus B whole square. Is that correct or not? So this will give us Ft into A plus B is equal to क्या? 1 मतलब A square plus 2 into A into B plus C square. Again V square by C square आएगा, उसको छोड़ देते हैं. So here you have this 1 plus 2V cos alpha by C. यहाँ से please derive the formula and find out the value of V. Fr is equal to Ft into 1 plus 2V cos alpha by C. Please derive the formula and give me the value of V.
Sir, we have to put the values now.
No. Formula में खाली.
Okay, sir.
We are just deriving the formula, not that we are doing any kind of calculations. Ankit Tomar, I want the answer from you. And also the other Ankit. Ankit, A for Arya, क्या है? Ankit?
सर आहूजा सर.
आहूजा, हाँ,
आहूजा.
sorry. हाँ. So आप दोनों से आंसर चाहिए. कैलकुलेट कीजिए, मतलब कैलकुलेट नहीं, डिराइव कीजिए. V का वैल्यू निकाल के देना.
सर कैमरा थोड़ा सा नीचे शिफ्ट कर सकते हैं प्लीज.
क्या हुआ?
सर थोड़ा सा कैमरा नीचे शिफ्ट कर दीजिए, दिख नहीं
नीचे
रहा.
करें. ओके. ओके, नीचे. नाउ?
यस सर, थैंक यू.
इतना टाइम क्यों लग रहा है? ऊपर का मैं मिटा रहा हूँ, मिटा दो ऊपर. तो Fr is equal to Ft, इसको मल्टीप्लाई कर दिया, प्लस 2v cos alpha by c, or fr minus ft is equal to 2v cos alpha by c, or v is equal to, इसको यहां छोड़ते हैं, बाकी सबको इधर लेके आते हैं, fr minus ft into c divided by 2ft cos alpha. Is it okay or not?
Yes, sir.
So we are able to calculate this V if we have the transmitted frequency 150 kilohertz. The received frequency, हमारे पास एनालाइजर, इलेक्ट्रॉनिक एनालाइजर होता है, जो सिग्नल आती है उसको इलेक्ट्रिकल में कन्वर्ट करके we can read the frequency क्या आया. So if 150 was transmitted, 151.2 आया, multiplied by 1500 divided by 2 into 150 kilohertz cos alpha, which is normally 60 degrees. सब वैल्यूज मिल गई तो v का वैल्यू निकल जाएगा कि नहीं? So this is the basic Doppler log. This is how it is working and how the speed is calculated. What we have done, in theory, we have to write in words that in the case of shape, a transducer is fitted at the bottom. The signal is transmitted at an angle alpha, usually 60 degrees. Because of the horizontal motion of the ship, which is v, there is an apparent motion of the ship towards the seabed, which is given by v cos alpha. Due to this relative motion, there is a change in the frequency, which is fr. Comparing the fr and ft, we can calculate the speed of the ship by this formula. आपको derivation नहीं करनी है. Derivation is not there for you. This is just to explain how things are coming. You should be confident when you are writing. जब आंसर लिख रहे हैं तो आपको पता है कि yes, what you are writing about, you know about it. So no derivations for you in the second phase 2. Second maths में है, आपके लिए ये नहीं, no derivation. So theory समझनी है, but this is to explain how things are working.
Okay.
In theory, you have to understand one problem with this basic Doppler log. We said, okay, is this done? Are we through with this? Anyone wants
Yes,
any explanation? कुछ चाहिए और? Any query?
No, sir.
Anyone? आपको तो नहीं है, और किसी को? Okay, no. So, what is the problem? इस जो अभी हमने किया, जो स्पीड निकाली हमने v is equal to so and so, इसमें कुछ प्रॉब्लम है क्या? Yes, there is. This formula cannot give us correct speed. Why not? Because let us think the ship is moving like this. She is in the water. Suppose engine is stopped, no movement at all. No movement at all. There is a wave coming. The ship goes up. the wave passes, the ship goes down. So if the ship is not moving forward, she is moving up and down. When the ship moves, she also moves up and down. Supposing the ship has gone down little bit like this. So the transducer which was transmitting earlier from here to here is now transmitting from here because the ship has gone down little bit. She has gone down at the speed of VV, vertical velocity. Now the reflection is happening from here. So again, is there a difference between the two distances?
Yes, sir.
That means there is a relative motion from this to this. There is a relative motion.
Yes, sir.
That means this relative motion is going to cause frequency shift. तो अगर आपने ft ट्रांसमिट किया था तो fr जो है वो चेंज होके मिलेगी या नहीं?
Yes, sir.
कितनी मिलेगी चेंज होकर के? How much of change will be there? Can this be done by the same way? If this was alpha, this angle is 90 minus alpha. Is that correct?
Yes, sir.
And so this one is alpha again. This is alpha. 90 minus alpha. ये 90 है तो ये अल्फा हो गया या नहीं?
Yes, sir. वो भी.
So in this one is VV. ये hypotenuse is VV, vertical velocity. Then what is the relative motion in this direction? जहां पे ट्रांसमिशन हो रही थी. A, B and C. What is AB is given VV. Then how much is this AC? That is the relative motion towards the seabed because of VV.
Sir, sine.
Yes, sin आएगा. Sin आएगा.
BB sin theta, BB sin theta.
BB sine. Yes.
थीटा को हम अल्फा बोल रहे हैं यहाँ. That means because of this VV, there is a relative motion which is VV sin alpha. But the ship was also moving forward. अभी तो हमने स्टेशनरी कर दिया था, पर जब जहाज चल रही है तो साथ में ऐसे ऊपर नीचे भी हो रही है. मतलब VV भी है और साथ में V भी है. तो दो रिलेटिव मोशन है. एक VV sin alpha because of this and V cos alpha because of this motion. So both the relative motions will get added up. So total relative motion is this V cos alpha plus VV sin alpha. Both are going to participate in frequency shift.
Yes, sir. The vertical and the horizontal.
The horizontal motion causing relative motion V cos alpha. The vertical motion VV causing VV sin alpha. Both are getting combined. अगर मैं इधर को चलता हूं तो आपके नजदीक जा रहा हूं. मैं इधर को चलता हूं साथ में इधर भी आ जाता हूं तो दोनों तरफ से मैं आपके नजदीक गया ना. दोनों मोशन ऐड हो गई.
Yes, sir.
So relative motion with respect to the camera, I am going here like this and also like this. So both the velocities got added up. So यहाँ पे relative motion दो हो गई. हमने जो अभी फॉर्मूला निकाला था उसमें इसको कंसीडर किया क्या?
नहीं सर.
नहीं किया. तो जो हमें FR मिल रही थी उसमें इसका भी रोल था लेकिन हमने काउंट किया नहीं उसको. जब हमने ट्रांसमिट किया सिग्नल यहाँ पे हमने v cos alpha लिया, the v was here, we transmitted ft, we received fr. जो fr आ रहे थे उसमें ये तो था ही, लेकिन vv cos alpha भी sin alpha भी तो था। ये जो चेंज हुई है इसके चलते और इसके चलते, दोनों के चलते हुई ना, वो हमने काउंट किया ही नहीं। So basic log has got a problem that we did not account for the vertical motion, or so to say heaving motion of the ship. Up and down motion of the ship is heaving. So in the basic log, this was not taken into account. So what do? We modify our Doppler log. We modify the Doppler log, which is known as Janus configuration log. Janus configuration Doppler log is based on a god, Roman god, whose name is Janus. Who is this god? He is the god who has got two faces. One looking in the past, other looking in the future. So he is the god who is looking forward and aft both. He looks also what is going to happen in the future, and also is able to look together the past at the same time. So if this is the god, then a Doppler log which is made on his name, what should the Doppler log in Janus configuration mode should do?
Send two acoustic signal, one forward and one aft.
अरे वाह, एकदम सही बात. So there is transmission happening. There are two sets of transducer, one transmitting forward at this angle alpha, one transmission happening at the same angle in the aft direction. The ship is going forward at the speed of v, but she is also going up and down. When she goes up, and also she goes down, which is vv. Because of the v, there is a relative motion which is v cos alpha forward में. If this is the seabed and the ship is going forward, इस point के नजदीक आती है और नीचे जाती है तो इसके नजदीक आती है, दूर जा रही है इससे.
नजदीक आ रही है.
नजदीक जा रही है, मतलब both will get added up, vv sin alpha. Now this transducer, because of v, the transducer is getting away from the this point of getting close to this one going this side. It is getting away or not? The ship going like this, from the point of reflection, this transducer is going away or not? भाई यहां से ट्रांसमिशन हो रही है, जहाज आगे चल रहा है, ठीक से दूर जा रहा है कि नहीं?
Yes, sir.
So the speed at which it is getting away is the same, but opposite. So this should be minus v cos alpha. Is that correct? If this was coming close to this v cos alpha, it is getting away from this minus v cos alpha. सही है या नहीं? Now when she is
Yes.
going down, she was coming close to this, so plus VB sin alpha. When coming down, what is happening to this? Is it coming close or getting away?
Coming close, sir.
Again coming close. तो मतलब यहाँ पे फिर भी plus VB sin alpha होगा. Both are coming close because of VB. जब नीचे जाती है तो दोनों के नजदीक जाती है. So there are two relative motions. हमने ft ही ट्रांसमिट किया इधर को, ft ही ट्रांसमिट किया इधर को, but fr which is going to come will be different. एक में कम होगा, एक में ज्यादा होगा. So now we have got two received frequencies. We will call them FRF and FRA. F for forward, F for A for aft. This A which is received from the aft transducer and FRF which is received from the forward transducer. So now in the next class, we will talk about the comparison of the two frequencies and how do we get a new formula for V in which we also account for the vertical motion. Because पहले डेरिवेशन में हमने सिर्फ V cos अल्फा लिया था, अब हम VB sin अल्फा भी लेंगे और दो तरफ लेंगे, फॉरवर्ड वाले से भी, आफ्ट वाले से भी.
Okay, sir.
Yes. So, are we good up to this? Any questions?
No, sir.
Anyone? Jaspreet? Naman? Nahin. Manan? Principle we saw the basic Doppler log, how it works. The principle we have seen. How the received comparison between received and transmitted frequency is processed in order to find out the speed of the shift. The reflection of the acoustic waves from the seabed is what is the reference we are taking. So the reference of the ship's speed is taken from the sea bottom, and that is how we are getting SOG, speed over ground. It has no reference as of now, no reference to the water. The water apart, whether flowing or not flowing does not matter. If the ship is moving with respect to the ground, that is what we measure. Frequency shift takes place only because of that. Yesterday we had seen the problem with the basic log. Can somebody remind me of the problem?
Sir, the earlier we were only considering the horizontal this resultant velocity, that V cos alpha, and but when ship moves, there is also vertical movement of the vessel up and down, which was earlier found out to be the relative motion was VV sin alpha. So for that we use this Janus configuration.
Ditto, no, nothing to add. So problem that we, as you repeated, as you said, was that we did not consider the vertical motion. If it is here, the seabed, if the ship is coming like this, there is a relative motion in this direction, yes. But when the ship is going down, that also gets added up. So there are two relative motions, which is contributing to frequency shift. जो हमारे पास FRI है, उसमें दोनों चीजें थी, लेकिन हमने कंसीडर किया एक को, only the horizontal motion. So in the Janus configuration mode, we are taking care of both the things. As also talked yesterday, that in Janus configuration, the Janus configuration is that it is having two transducers, two rather sets of transducers. Transmission reception forward, transmission reception from R. So दो received frequencies आती है हमारे पास. Transmission frequency एक ही है, दोनों तरफ ट्रांसमिट कर रहे हैं, FT एक ही है कॉमन, but received frequency is coming from forward as well as from up, both the sides. So this can be understood again. This configuration cancels out the effect of heaving motion. How it is happening, we can see it in the form of derivation, but आपके लिए derivation नहीं है. As already indicated yesterday, derivation is not required for you in the examination, it is only the theory. But to understand the theory, थोड़ा सा अगर हम इसको logically समझें, so it becomes easier. We understand what we are writing about. We are confident about the answer. So we'll go to the board to just understand slightly this configuration. Board deep में नहीं जाएंगे, but just we will understand. Before that, when we were doing this derivation or we were studying about this, तो उसमें हमने देखा था कि there was a step coming where FR minus FT was something like 2B FT cos alpha by C. Is that correct?
Yes, sir.
FR minus FT is equal to 2B FT cos alpha by C. तो बोर्ड पे चलते हैं एक बार. Let me see that FR is equal, sorry, FR, अच्छा चलो ठीक है, minus FT is equal to 2B FT cos alpha by C. This was when we are considering V cos alpha. Supposing the shape is just dipping down little bit. The transducer is here. When she is going down at VV, vertical velocity, because of this, is she coming close to this point or not? Point of reflection here.
Yes, sir.
So this VV is also causing a relative motion with respect to the same transmission point. In this, we had seen that this is VV sin alpha, the relative motion. अगर हम इसी प्रोसेस को VV sin alpha के साथ प्रोसेस करते, तो here we would have got the same thing to VVFT sin alpha by C. अगर सिर्फ वर्टिकल मोशन होता तो ये आती. Difference between transmitted and received would have been this. दोनों चीज है तो दोनों एड अप हो जाएगा. जो डिफरेंस है ट्रांसमिटेड एंड रिसीव्ड is because of this as well as because of this. तो ये तो आगे गया ही प्लस ये और ये तो नजदीक गया प्लस ये और नजदीक गया. So as you can see, the relative motion which is taking place is this much. So what actually do we have? Since we have two transducers and two received frequencies, we will process both of them. So for the forward transducer, what happens? The FRF, now FRF for forward, and the difference between FT and this is because of two components, a horizontal component 2VFT cos alpha by C. This difference is also caused because of the horizontal motion. So plus 2VVFT sin alpha by C. So this is for horizontal motion. This one is for vertical motion. Both of these are causing the difference between the transmitted and received frequency. As we have already seen that here there are two relative motion, V cos alpha plus VV sin alpha. And on the aft, we had a negative speed minus V cos alpha and plus VV sin alpha. Because जब नीचे जा रही है, जहाज नीचे जाएगा तो दोनों के नजदीक जा रहा है, तो दोनों प्लस हो जाएंगे. लेकिन this transducer getting away from this point and this one closing towards the point. So this is positive, this is negative. So when we process, we have to take this one as negative value. So this was for forward transducer where both are positive. Both components are positive. When we are working with the half transducer, the equation will be FRA minus FT is equal to minus 2VFT. चीज तो वही रहेगा, बट सिर्फ साइन चेंज हो जाएगा. FT cos alpha by C प्लस ये दोनों साइन एक ही था, सो प्लस 2VVFT sin alpha by C. Let this be equation number 1, this equation number 2. We subtract 2 from 1, that means 1 minus 2. LHS को अलग, RHS को अलग. So this gives us FRF minus FT minus FRA minus FT. LHS हो गया, this minus this is equal to this minus this. So here we have 2VFT cos alpha by C plus 2VVFT sin alpha by C. This one minus this equation is 2VFT cos alpha by C plus, sorry, this one is, this equation is minus. This is minus, so this is minus. Plus 2VVFT sin alpha by C. If we simply process it, minus plus, minus, minus minus, plus, again here, minus minus, plus, minus plus, minus. So here, this FT and FT gets cancelled out because minus FT and plus FT. Similarly, on the right hand side, we have plus 2VVFT sin alpha. Here we have minus 2VVFT sin alpha. Same equation, but opposite signs. So the two are getting cancelled out. मैं ऊपर में थोड़ा सा डिलीट कर रहा हूं, ये दो इक्वेशन हटाऊं.
Yes, sir.
So that leaves us FRF minus FRA is equal to, this is 2 plus 2, so 4 VFT cos alpha by C. And from here we can find out this value of V, which is equal to FRF minus FRA into C divided by 4FT cos alpha. So in this equation, what do we see? The effect of vertical component is cancelled out. In the Janus configuration, there is no effect of the heaving motion. Those two quantities are getting cancelled out when we compare not the transmitted and received frequency, but received and received frequency. Received from forward and received from aft. When we are comparing these two, not as we were doing earlier, where FR minus FT was there. So, what is the benefit of Janus configuration? How it is achieving accuracy?
The vertical
It
motion
is-
is cancelled out.
Very good. Vertical motion, effect of vertical motion is cancelled out on the indicated speed. This speed which is shown on the display here. This is the speed which is shown here. Behind this, some processing is going where inputs are taken, which is FR, C, alpha, FT. Now, if the ship goes up and down, it changes FRF and FRA, yes, but the difference between the two makes it independent of that heaving motion separately. अलग से उस relative motion का फर्क नहीं पड़ रहा है. So this is what is the achievement of genus configuration. Additionally, this genus configuration also provides better speed when we are taking the case of trim. Trim के केस में भी ये effective रहता है to quite a large extent. When we are talking about something like, pitching, there also it is useful. Something called side lobe error. There also it is helpful. So additionally, apart from heaving, it also takes care of the difference of displayed speed when there is a trim, when the ship is pitching, or there is side lobe error. In that also it is useful. We will talk about all this separately. आगे आएगा. So we have seen the basic log, we have seen the genus configuration. Remember that when the genus configuration या question पूछा जाता है कि what are the benefits of genus configuration, you don't have to derive all this, but you can write it in text that it eliminates the error due to heaving motion, it cancels out the effect of heaving motion. Additionally, it is also taking care of trim, pitch and side lobes. So trim का case हम बता सकते हैं कि how it is going to help us out in the trimming case or the trim case. Before we go to the trim, another topic or subtopic rather. Can I rub it?
Yes, sir.
Dual axis Doppler log. When the ship is going for berthing, jetty पे जा रही जहाज, she is moving generally athwartship direction. She is not moving forward, not going aft, but she is going sideways. The Doppler log that we have seen so far, was transmitting in the forward and aft direction genus configuration. Since the vessel is not moving forward, is she going to give us this speed?
No, sir.
Transmission happening like this, but it is going. So no relative motion being observed forward and aft. And so this cannot give us the athwartship speed. But for berthing and berthing operations, I require this speed, athwartship speed. So how do I get it? So in the shape, there is not only forward and aft transducer, but there is also port and starboard transducer. So these two working for forward aft speed, and these two are working for athwartship speed. Same way as it is working for this, it also works for this. So there is something called 4-element something called 4-element transducer array, which is transmitting in forward half direction as well as post starboard direction. Same way, same calculation, everything same. When the ship is going sideways, there is one transducer which is receiving frequency increased, other one starboard side decreasing frequency. So now there is not FRF and FRA, but FRP and FRS. No difference. Just that
Yes,
two different sets of transducer. They are housed together. एक ही में बना होता है. एक डब्बा है, एक इधर को ट्रांसमिशन, एक इधर को, एक उधर को, एक इधर को. डब्बा एक ही होता है. That is what we are calling 4-element transducer array.
Understood, sir.
So basically, that is dual axis is very useful when we want the athwartship speed. As it is, we know that ground speed is required more for coastal navigation, and berthing and unberthing operation is again with respect to ground only. Jetty fixed है, मैं move करता हूँ, तो ground का ही speed चाहिए, but athwartship क्योंकि जहाज sideways move करती है. Now, next, we know that the ship is fitted with a transducer. It is transmitting in forward half direction. The angle is alpha. So if, let us say, considering that this is also parallel, so this is also alpha. But in most cases, the ship is not upright. We are talking about what happens when the ship is trimmed. Normally, the ship is not going to be sailing even keel. She is trimmed little by either stern or down by head also it can go, but normally this is the condition. तो पहले हम इस condition के बारे में बात करते हैं. Since the transducer is fitted with the ship और जहाज ऐसे पीछे झुक गई है, तो transmission also goes like this. So what happened, supposing this trim angle was beta, then what do we observe here, or rather this one. This is the horizontal line. अगर देखें, so what has happened to the transmission angle here and what has happened to transmission angle here? Forward में क्या हो गया?
सर हाफ में माइनस हो जाएगा बीटा, फॉरवर्ड में प्लस हो जाएगा.
आप देख रहे हो ये माइनस हो रहा है कि प्लस हो रहा है?
नहीं सर, प्लस हो रहा है, सॉरी.
और यहाँ पे
यहाँ माइनस हो जाएगा.
जो पहले ये था ये माइनस हो गया ना. आप ये देखो एंगल छोटा हो गया और ये एंगल
Yes,
बड़ी हो
sir.
गई कि नहीं?
उल्टा बोल दिया मैंने.
उल्टा. So ये होता है, ये कोई प्रॉब्लम नहीं है. This is so very often understood like this. Even I thought initially it will happen like this. So in this case, the forward angle is alpha minus beta, and the aft angle is alpha plus beta. Angle of transmission change हुआ, तो आगे में जो relative speed है वो cos alpha minus beta हो जाएगा. Aft में जो motion है, relative motion, that will be cos alpha minus beta, sorry, plus beta. So how is this going to impact the displayed speed? अगर relative motion change हुआ तो frequency shift change होगी. FRA चेंज हो गया, FRP चेंज हो गया, सॉरी FRF चेंज हो गया। यहाँ पे रिलेटिव मोशन चेंज हुई cos अल्फा प्लस बीटा, तो यहाँ भी चेंज हो जाएगा, FRA है वो भी चेंज हो जाएगा। सो FRA minus FRF minus FRA, the value is changing, input is changing, so Doppler log का display should change, isn't it? So in what manner this will change? How is it going to show in effect in the displayed speed? Do we remember that we had FRF minus FT is equal to 2B FT cos alpha by C? अब हम साइन अल्फा को छोड़ दे रहे हैं, dv साइन अल्फा को छोड़ दे रहे हैं, क्योंकि हमने देख लिया जेनस कॉन्फ़िगरेशन में उसका काम तमाम हो गया। So the difference between transmitted and forward received frequency is now given by this. But now the angle has changed here. This is alpha minus beta in the forward. And in the aft transducer, what is happening? It is FRA minus FT is equal to minus 2VFT cos alpha plus beta by C. So again we make a comparison. Again we are going to go at here FRF minus FRA. FT cancel हो जाएगा. But this we know cos alpha minus beta and cos alpha plus beta, there is an expression when expanded. Okay, इसको बाद में करते हैं. Cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta, and cos alpha plus beta is equal to same, but it is with minus sign. Cos alpha cos beta minus sin alpha sin beta. So can you please replace the values here? मैं इसको मिटा रहा हूं, इसके नीचे आता हूं. We know this. So now what we have is FRF minus FRA. अगर हम माइनस करें तो इसमें से 2VFT by C हम लोग कॉमन ले लेंगे. 2VFT by C कॉमन ले लेंगे इन दोनों में से. यहाँ माइनस और माइनस था तो वो प्लस हो जाएगा, of course. So here we have cos alpha minus beta plus cos alpha plus beta. We put the expanded value. So this is cos alpha cos beta plus sin alpha sin beta alpha plus cos alpha, अब ये वाला एक्सप्रेशन cos alpha cos beta minus sin alpha sin beta. Here we have plus sin alpha sin beta, here we have minus sin alpha minus sin. This is cos alpha cos beta plus cos alpha cos beta. So 2 cos alpha cos beta हो गया. मैं ऊपर वाला मिटा रहा हूँ जरा सा.
Yes.
So that gives us FRF minus FRA is equal to 2BFT by C into ये 2 into 2 4 हो गया. 2 cos alpha cos beta. That means this is basically 4 cos alpha cos beta. And from here we can find out the value of B. Please do this for me. B is equal to
C into FRF minus FRA by 4FT cos alpha cos beta.
very good. So it is C into FRF minus FRA divided by 4FT cos alpha cos beta. Are you seeing the observation? Is your observation there that this much is the same as it was before? What is getting added up is 1 by cos beta. Is that correct?
Yes.
So if there is a trim angle of beta, the displayed speed will get affected by 1 by cos beta. What does it mean? Will it increase or decrease? So the actual speed, if let us say it was 15 knots, if the actual speed was 15 knots and there is an angle of trim, so this will become cos beta. Correct or not?
Yes, sir.
Now suppose this is the actual speed. And cos beta is 0. That means beta is 0. So this will be the indicated speed divided by 1. अगर कोई trim नहीं है, 0 trim है, तो actual speed and indicated speed will be same.
Yes, sir.
Okay. Now suppose the ship is going at 15 knots. Actually she is moving at 15 knots. Indicated speed भी 15 दिखा रहा है. As this vessel is moving, थोड़ा सा trim हुआ. Trim क्या? Pitch हुआ. Down by stern गया. तो क्या स्पीड चेंज हो गई जहाज की? वो 15 नॉट पे चल रही थी तो 14 हो गई क्या? ये सिर्फ ये चेंज हुआ है.
यस सर, वो इंक्रीज कर जाएगी अगर.
तो रिमेंबर, ये जो चेंज हुआ है इसके चलते अल्फा और बीटा का चेंज हुआ.
यस सर.
दैट मींस द FRA एंड FR का इनपुट है, दैट इज चेंजिंग टू द प्रोसेसर.
यस सर.
That means input is changing. That means this will change. The actual speed was 15 knots, but the inputs to the processor has changed. That means indicated speed will change. Now this is, let us say, 0.98. So anything divided by a number less than 1, this is going to be 15 knots. तो ये ज्यादा होना चाहिए या कम होना चाहिए ताकि रिजल्ट इसका 15 आए?
कम होना चाहिए सर।
कम होना चाहिए। अगर इंडिकेटेड स्पीड करना है तो हम इसको लेके जाएंगे तो इतना आएगा,
यस
इतना इंडिकेटेड स्पीड होगा। दैट
यस
मीन्स
सर।
the indicated speed becomes less. Not going by the value, just to indicate ऊपर नीचे जो हो रहा है सर को, अभी कैलकुलेशन का एक्यूरेसी मैंने बात कर। So when there is a trim angle, the indicated speed is less than the actual speed. अगर जहाज 12 की स्पीड पे चल रही है तो इंडिकेटेड 11 पॉइंट समथिंग दिखाएगा। अगर 14 पे चल रही है एक्चुअल तो 13 पॉइंट समथिंग दिखाएगा। Or conversely, what we can say that if there is a trim and if we are seeing 15 knots in the indicated speed, what do we understand?
The speed is higher sir.
जो स्पीड है वो 0.01, 02, 03 से ऊपर होगा।
Yes, actual speed will be higher.
Actual speed will be high. So indicated speed is always showing less than the actual speed. हमारा स्पीड ये नहीं बढ़ जाता है, हमारा स्पीड ये डिस्प्लेड स्पीड कम हो जाता है। ये कम हो गया तो ये बढ़ गया। So what relationship we are saying? This was the indicated speed divided by cos beta. So what we take from here is that in the case of trim, actual speed is equal to indicated speed by cos beta. So this is what is happening in case of trim. That means how much of change took place between the two? This beta angle, the trim angle will be very, very less. ये ज्यादा होएगा।
Will be less sir.
What is the maximum allowable trim? Okay, before we go to that, when the ship is down by head, when the ship is down by head, उल्टा हो जाता है, इधर में अल्फा प्लस बीटा, इधर अल्फा माइनस बीटा हो जाता है। जब हम इक्वेशंस को प्रोसेस करेंगे तो साइन का जगह बदल गया लेकिन साइन वही रहती है, फिर से कैंसिल आउट हो जाएगा साइन अल्फा साइन बीटा और नेट रिजल्ट वही होगा। सो आइदर डाउन बाय स्टर्न और डाउन बाय हेड, इन बोथ द केसेस इट इज एक्चुअल स्पीड is equal to indicated speed by cos trim angle. So the indicated speed is always less than the actual speed or equal. अगर ये बीटा एंगल 0 है तो cos 0 is equal to 1, तो दोनों बराबर दिखाएगा। डाउन बाय हेड गया, डाउन बाय हेड गया तो नीचे, डाउन बाय स्टर्न गया तो नीचे। So it fluctuates or it is going either equal or less than equal to the actual speed. So we have seen that it is going less, but how much? Should I be worried? Should it affect my ETA calculation? Will it affect the time of collision with a ground object? Is it going to be too much difference? Let us see how much of difference is taking place. For a ship, maximum allowed trim as per MARPOL regulations is 1.5% of the LOA. That means if the length of the ship is 100 meters, there can be difference of draft between the two, which is 1.5 meter. So if the ship is trimmed like this, if the ship is trimmed like this, this is 100 meters, then this is 1.5 meters. This is the angle of trim which we are calling beta. So in this right angle triangle, we have this and we have this, perpendicular and base. इस angle के सामने वाला perpendicular and base. So can we say tan beta is equal to 100 meters? No, sorry, 1.5 meters divided by 100. This angle tan of this is equal to perpendicular by base.
Yes, sir.
That means beta is equal to tan inverse 1.5 by 100. If we calculate, we find that this is something like 0.86 degrees. So the maximum allowable trim is 0.86 degrees. अगर ये 200 मीटर होता तो ये 3 मीटर होता, रेशियो वही होती. So maximum allowable trim is this much. So how does it impact our displayed speed? Suppose the ship was doing 15 knots. There is some kind of indicated speed divided by cos beta is cos 0.86 degrees. Divided by this should be 15 knots. So of course indicated speed is equal to 15 cos 0.86. So can you tell me what is the indicated speed here? Please calculate.
So 14.998.
Okay, so what we are saying is we are going to get 14.99. So because of maximum trim allowed, the speed indication has changed by 0.01. Actual speed is 15, but it is showing 14.99. Should I be worried?
No, sir.
Exactly. So the genus configuration also takes care of this trim case, whether down by head or down by stern. The indication changes, but it is negligible, which can very well be omitted for any kind of due consideration. So we have already seen that it is good for heaving case. Heaving में हमने देखा कि heaving का इफेक्ट ही जो अप एंड डाउन मोशन थे उसका इम्पैक्ट खत्म हो गया जेनस कॉन्फ़िगरेशन में. हमने ट्रिम के केस में देख लिया कॉस बीटा आ जाती है. सो ट्रिम also taken care of, the speed indication is changing but not so much, does not matter. When the ship is pitching, which is a constant changing, एक बार इधर को नीचे, एक बार इधर को नीचे, एक बार इधर को, जहाज ऊपर नीचे, हेड ऊपर नीचे होता है. So this will keep on fluctuating. When it is even keel, तो ये 15 हो जाएगा. जब डाउन बाय हेड 14.99, डाउन बाय स्टर्न 14.9, between 15 and a value less than 15, 14 point something. Either 15 जाएगा, जब कुछ एंगल बनेगा यहाँ पे तो it will go 14 point something. So this is also good in case of pitching. We don't see much of difference in the speed. Yes, it is fluctuating, but not something that should worry me, that I should be concerned about.
Yes, sir.
So,
Understood.
are we good about this? Trim case?
Yes, sir.
We have another situation. What is the effect of various motions of the ship on the indicated speed? Now that we have seen that Doppler log is a function of the angle at which it is transmitting, that is the major role or major factor which changes with, that changes condition to condition. Ship is floating and she is moving at the sea. She is subjected to the elements. That means subjected to the water. And in doing so, she is moving. What kind of movement do we see in the ship? When the ship is moving, we of course see first one, heaving, up and down motion of the ship. We see rolling, sideways motion. Then we also see pitching. Additionally, we also see something called yawing. Yawing is changing heading. जहाज जब पानी में बैड वेदर में चलती है तो ऐसे 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 करके उसका हेडिंग चेंज होता रहता है. So how are these motions going to affect the displayed speed? So these are the ship motion basically. Now the Doppler log that we have already made dual axis. So there will be forward aft speed and there will be port starboard speed. So we will see head to head comparison between forward aft speed and port starboard speed. Now that we have learnt about Doppler log so much, what will be the effect on the forward aft speed when the ship is heaving? Yes. Rishabh, Anmol, Mr. Sheel.
सर फॉरवर्ड आउट में तो नेग्लिजिबल रहेगा ना हीविंग का इफेक्ट.
नेग्लिजिबल नहीं, नील होएगा. हमने कैंसिल कर दिया था या नहीं वी विल साइन अल्फा?
Yes, sir.
जब वहां पे कैंसिल किया था पोर्ट स्टारबोर्ड में क्या होगा?
So वहां पे भी कैंसिल होगा.
वहां पे भी कैंसिल होगा. सो नो इफेक्ट ऑन दिस एज वेल. हीविंग का कोई इफेक्ट नहीं होता किसी के ऊपर. Now when the ship is rolling, there is transducer sideways. So is the angle changing? Angle of transmission sideways, is it changing?
Yes, sir.
That means there should be some effect similar to cos beta.
Yes, sir.
What about this? When it is happening like this, rolling, the forward up transducer, is it going to cause any angle change?
No, sir.
No. So very intuitively we can say that there is no effect on the of the rolling on this, but this will be actual speed is equal to indicated speed by cos list or roll angle. जैसे ही लिस्टिंग होगी या रोल करेगा तो रोल एंगल के साथ इंडिकेटेड स्पीड विल आल्सो फ्लक्चुएट. हाउ? इंडिकेटेड स्पीड डिवाइडेड बाय कॉस लिस्ट विल बी द एक्चुअल स्पीड. पिचिंग के केस में क्या होगा? Pitching is similar to trim. Just now we talked.
Yes, sir.
So will it be similar to this?
No, sir.
Why not?
Yes, sir, it will be similar, but port and starboard will be neglect, no change.
Exactly, nil here. But this will be indicated speed divided by cos pitch angle. Yawing. When the ship is yawing, constantly changing heading, is it going to do anything to port starboard or forward aft transducer? Any angle change, etc. when the heading is changing?
No, sir.
So no effect of yawing on this or this. So we have covered this different kind of the genus configuration we saw. We saw what happens when the ship is trimmed either by head or by stern, how the indicated speed is going to change. We have understood it by formula derivation also, but again repeating, आपको एग्जाम में उसकी जरूरत नहीं है. दे देंगे तो अलग बात है, but आपको जरूरत नहीं है. You are requested or you are expected to write in theory and rather beautifully, because you are now senior officers, so you should be able to write in more expressive manner as to what you want to say. Maybe formula इधर उधर जगह दिखा सकते हैं, show कर सकते हैं, but derivations are not required as per your syllabus. Are we good?
Yes, sir. Understood.
Errors of Doppler log. An important question. We will not discuss in detail अभी, अगले क्लास में डिटेल में बात कर लेंगे. But just to get a hint, we know that V is given by FRF, FRA into C divided by 4FD cos alpha. We are talking about errors of Doppler log, मतलब जो indicated speed है उसमें गड़बड़ है. कोई आउटपुट गड़बड़ क्यों होगी? जब इनपुट गड़बड़ होगा. These are the inputs which gives me the output, displayed speed. So can you identify the factors which can cause problem in the or error in the output?
Yes, sir. The salinity of the change in salinity of the water.
Number one, the propagation of the speed c, which is 1500 meter per second, will change as per the salinity, temperature, etc., etc. Input gone wrong, output gone wrong.
Yes, sir.
We are transmitting FT, but because of frequency drift, इलेक्ट्रॉनिक सर्किट में थोड़ा सा टेम्परेचर वगैरह से फर्क पड़ता है, तो उसकी फ्रीक्वेंसी चेंज हो गई. हमने बताया 150 किलोहर्ट्ज, now it is transmitting 150.01 kilohertz. So number 2 can be error in the transmitted frequency or oscillator frequency. Then we are receiving the signal which is reflected back, converting it into electrical signal and analyzing कि कितना receive किया. That is what we get FR and FRA. If we have a problem in reading this measurement of frequency received, then this can be another source of error. So 1, 2, 3 error sources we have seen. Can we see something else also here?
No, sir.
No. What about this? आपने जहाज में बोला कि हमने 60 डिग्री लगाई है, और जब नट बोल्ट टाइट किया तो वो ट्रांसमिट कर रही है यहाँ पे. This is the actual angle at which it is transmitting, this one. But आपने उसको बता रखा है कि मैंने 60 डिग्री पे फिट किया है. So it is taking always 60 degree, but you are transmitting at 62 degree. Transducer orientation. So normally when we talk about errors of Doppler log, we have 6 kind of errors, out of which 4 are there in the formula itself. If we remember this formula, we can identify क्या क्या errors थे. Number 1, number 2, 3, 4. 2 और हैं जो अगले क्लास में डिस्कस करेंगे. Time has run short, so अगले क्लास में हम लोग कल है क्लास हमारी. We'll discuss this and most likely we'll be able to complete this topic tomorrow. Any questions?
No, sir. Understood.
पक्की बात? मनीष जी, मनीष भाई कहाँ है?
Yes, sir, President.
Okay, good. Yes, sir. So yesterday, last 2 classes we did echo sounder. We will complete that also, but we had left Doppler log in between. Last little bit was remaining, so we will complete that Doppler log in totality so that we are done with the topic. So just for the review of the Doppler log, we saw the principle, we saw the basic log, we saw the problem with the basic log, then we modified it to genus configuration. We saw the benefit of genus configuration. In conclusion, we had seen that the heaving motion was ruled out, it was cancelled out. So vertical component was cancelled out. The genus log is free, genus configuration Doppler log is free of heaving motion effects. We also saw the dual axis. The special need for dual axis is when we are berthing and unberthing, because we need to have sideways speed of the ship more than the forward ship movement. So we saw dual axis. Then we also observed that what are the different effects that the log is facing when the ship is subjected to motions, various motions at sea. As the ship is moving, there are various kind of motions, rolling, pitching, heaving, etc. So we had seen that as well. We also saw when the ship is trimmed, how the speed indication changes. The speed indication, actual speed is more than the indicated speed. Actually, the indication goes down when there is trim, either by stern or by head. So these are what we have done already. Then we were talking about the next topic is what are the errors that the genus configuration may have, or the Doppler log as a whole may have. In the Doppler log, there are sources. Basically what it is a processor, a small computer, which gets inputs and gives out the result as a display. Any input which is changing will lead to change in the output. So from the formula itself, which gives us the output V based on the inputs FR, FT, alpha, etc., etc. So anything on the RHS, that is the input side, is changing, it will result in the change in the displayed speed. I think in the last class we had identified what are these inputs that can change. We had value of C, which we take as 1500 meter per second. But when the ship goes from one water to the different type of water, the salinity, temperature, etc. keeps on changing, and that changes the speed of the sound waves through the water. That will lead to error in the displayed speed. However, to compensate for the temperature difference, there is a thermistor which is installed near the transducer itself. So when the ship is submerged, the transducer is here. There is also a thermistor which is taking the temperature of the water. But of course, it is near the transducer. Down below, at a depth, the sunlight is not reaching, so normally it remains cold. So anyway, sea water near the surface, that kind of correction is given to the Doppler log. Based on the temperature, it changes the speed of C in the input so that it is doing little bit of correction to the speed indicated. However, salinity के लिए कुछ नहीं है, so that may be little bit of problem. Second one is transmitted frequency. If you remember, the processor is giving signal to the oscillator, जहाँ पे oscillator is producing electrical alternating current. At a given frequency, it is being generated, the electrical signal, which is given to the transducer. Now the oscillator has to be very stable, must produce the same frequency all the time. But electronic circuits basically is also somewhat temperature dependent. You might remember from your academic classes that the resistance of a conductor changes with temperature. That means in a circuit where the currents are flowing, if the circuit is hot or cold, the property of the circuits will change, and that may lead to little bit of deviation of the frequency. So the processor may be given a given kind of frequency, but the oscillator is producing something else. There can be difference between the two. That will lead to error in the displayed speed. To compensate for this, only what we can do is build a better kind of circuit. तो उसमें कुछ चीजें होती हैं, फीडबैक सिस्टम होता है कि फ्रीक्वेंसी चेंज होती है तो फीडबैक चेंज होता है तो उसे वापस फ्रीक्वेंसी स्टेबलाइजर्स होते हैं. The frequency stabilizers are there. So good kind of circuit may reduce this problem. Next one is measurement of the received frequency. वहाँ error हो सकती है. Transducer is converting sound waves into electrical signal जो receiver receive करके amplify करके और आगे देता है recorder को, analyze करने के लिए processor को. तो उसमें अगर रीडिंग के डिफरेंस हुए, then again there will be problem. Other factor which is there is the installation problem. When we are fitting the transducer, nut bolt tight करते हैं तो उसका angle थोड़ा सा change हो गया. That may also lead to little bit of error. Angle what we have given to the processor is 60 degrees. We are transmitting actually at 61, 62, 59, 58 degrees. So V cos alpha की वैल्यू बदल जाएगी. अल्फा हम बता रहे हैं 60 और वहां 61 पे ट्रांसमिट हो रहा है. So these four factors can be taken out from the formula itself. Other kind of errors, some of them are dynamic. Rolling pitching वगैरह के बारे में हमने बात किया है कि कैसे चेंज होता है. That may introduce error. But yet there is another kind of motion that we can talk about. It is when the ship is transmitting, it is at a certain angle. But by the time the signal is coming back, the ship is at a different angle. Because there is continuous motion of the ship. During the transmission and reception, there are two angles, transmission at one angle, reception at other angle. This also leads to error. How much of error? As it is said in the documents, that a 2-degree change between transmission and reception can lead to about 0.1% error in the indicated speed. Of course, it is not too much, so it can be neglected, but yes, there can be a little bit of error. The last one is something called side lobe error. If you remember the genus configuration, वहां पे हमने बात किया था कि genus configuration eliminates the effects of heaving, vertical motion का कोई impact नहीं होता. Additionally, genus configuration takes care of various errors like due to rolling, pitching, trim, and also side lobe. And I had said कि side lobe के बारे में बाद में बात करेंगे. Here we are talking about side lobe. So first thing that we should understand, what is the side lobe? मैं बोल रहा हूं अभी, मेरा मुंह इस तरफ को है. The energy is being transmitted in this direction more, but of course it is going other sides as well. So somebody behind also can listen to me because the sound wave is traveling there as well. When I try to localize it like this by making the diaphragm or whatever construction, when I try to narrow down my transmission, then the energy is mostly concentrated here. Less energy is going to the side, but it is going to the sides as well. Major part of energy is traveling forward, but side में थोड़ा कम transmission होता है. इसको कैसे रिप्रेजेंट करें? अगर मुझको बताना होगा कि कैसे ट्रांसमिशन हो रही है, तो पेपर पे मैं कुछ ड्राइंग बना के बताऊंगा. So let me tell you on the board how we are going to talk about the energy being radiated and in what directions and how. So when we are transmitting the signal in a given direction or in a given way, that can be represented by a diagram. That can be represented by a diagram. So here is the shape which is transmitting signal. We have been always making the diagram like this. But of course, the transmission does not take place as a laser beam. the transmission is taking place as a beam of certain width. Aft also it is being transmitted as a beam. Now what is this thing? The shape is the radiation which is happening in which direction and at what angle. So we have also seen earlier that this is known as the beam width. Actually not the full thing, but half power point के basis पे ये beam width होता है. And there is also sideways energy being transmitted. Similarly, this side also. So what we are trying to do here is representing the radiation of the wave on the piece of the paper. In this diagram, I have to talk about this and this and this. So this is referred to as the main lobe, and these ones are known as side lobes. आपने लोब सुना होगा. What is lobe? Any idea? लोब पहले सुना है? LOBE.
जी सर.
सुना है? इसको क्या बोलते हैं?
लोब, ईयर लोब.
ईयर लोब. तो ऐसे लटका हुआ है ना. Similarly, this also is referred to as lobe, but here is the transmission or radiation lobe. So the energy is being transmitted like this. What happens sometimes, especially on the sloping surface or seabed, that this energy is getting reflected back at better favorable angle. जो side lobe वाली transmission है, that gets reflected back and received by the transducer in a better way than the signal coming from here. This happens especially, as we said, on a sloping surface. तो ये favorable angle मिल जाता है इसको side lobe वाले को. तो यहाँ से transmission receive करने लगता है ज़्यादा strong signal आती है. तो basically अगर ये देखें तो angle change हो गया. It's all about changing the angle. So when the surface is sloping something like this, also this comes into effect. Here this angle also changes, kind of. So ये alpha minus beta वाला case हो गया. Alpha minus beta का case हो गया, तो trim का case that we are talking about, and there will be a slight difference in the indicated speed, but we have already understood that due to this, the error which is coming is negligible. So what we can say that the side lobe error is minimized by the genus configuration where we have two transducers, one transmitting forward, other transmitting in the aft direction. So these are the errors of the Doppler log. Very prominent question in the Doppler log for you is that how genus configuration minimizes various kind of errors. So you must talk about genus configuration. पहला आपको बेसिक के बारे में बात करना चाहिए कि क्या होता है उसमें. उसमें सिर्फ फॉर्मूला लिख के बता देना, उसमें प्रॉब्लम फिर आपको बतानी है. इससे जेनस कॉन्फ़िगरेशन में हम कैसे ठीक करते हैं वो बताना है. Then the formula, you have to give the formula. कि बेसिक लॉग ऐसा था, उसमें ये प्रॉब्लम थी. जबकि जेनस कॉन्फ़िगरेशन में क्या होता है, दो ट्रांसड्यूसर लगाते हैं फॉरवर्ड आफ्ट में. वो सब करने के बाद the speed is now given like this. इसमें आप नोट कर सकते हैं कि the difference is taken between received frequency from forward and up. And then what is the benefit of this? That it eliminates the sine component, that is due to vertical motion VV, and the Janus configuration is now free of heaving motion effects. Additionally, आपको also you should mention that in case of trim, how this Janus configuration is helping out. That means there is error, yes, but it is so small that it can be neglected. You have to talk about ship motion. How in dual axis log, various motions are not producing so much of significant effect. You also have to talk about side lobe. That also you can indicate here. तो शिप मोशन में रोलिंग पिचिंग वगैरह आ जाएगा, ट्रिम आ जाएगा, साइड लोब आ जाएगा. So in text only we have to indicate all this. Basic log में क्या होता है, स्पीड की फॉर्मूला क्या होती है, उस फॉर्मूले में आपने प्रॉब्लम क्या देखा, उसको ठीक कैसे किया जेनस कॉन्फ़िगरेशन में, जेनस कॉन्फ़िगरेशन के बाद स्पीड के फॉर्मूला में क्या डिफरेंस आ जाता है, फॉर्मूला के बाद कंक्लूजन क्या निकला. एडिशनली ट्रिम के केस में सिर्फ फॉर्मूला लिख करके बता सकते हैं. इसमें लिख सकते हैं कि ट्रिम के केस में एक्चुअल स्पीड इज इक्वल टू इंडिकेटेड स्पीड बाय cos थीटा, etc etc. So you can talk about all this as to what are the how Janus configuration minimizes various kind of errors in the Doppler log.
सर ट्रिम के केस में सर वो अगर एग्जांपल लेके बता देंगे कि एज पर रैम्बो रूल्स द मैक्सिमम ट्रिम अलाउड इज लाइक 1. जितना परसेंटेज आपने लास्ट टाइम बताया था,
हाँ, तो 1.5%
1.5% ऑफ द लेंथ, तो उसके अकॉर्डिंग अगर कोई बात दिखा देंगे कि इट्स ऑलमोस्ट नेग्लिजिबल व्हेन वी पुट इन द फार्मूला. सो ऐसे
yes,
वो
you can do that. You can do that. It is not expected of you. It is not expected of you to show it like that so much detail में. But अगर आप दिखा देंगे तो nothing like it. It is going to only help कि देखो ट्रिम की अगर होती भी है तो इतना ही होता है 14.9, and अगर 15 का स्पीड है तो 14.99 जाएगा अगर 0.86 डिग्रीज का ट्रिम है तो.
ओके.
So maximum trim allowed will be 0.86 degrees only. 100 मीटर है तो 1.5 मीटर का ट्रिम, 200 मीटर है तो 3 मीटर्स का ट्रिम, 150 मीटर है तो अकॉर्डिंगली 1.5% ऑफ द LOA. अल्टीमेटली वो उतना ही ट्रिम का एंगल इज मैक्सिमम अलाउड इज 0.86 डिग्रीज.
तो साइड लोब को कैसे एक्सप्लेन करेंगे बेसिकली सर इस केस में अगर
theoretical if you are writing, let us say what I have written, I am speaking. When the transducer is transmitting, the beam is transmitted, the waves are transmitted as a beam which is concentrated at an angle of alpha. However, due to constraints of the design, there are also radiations happening around the main beam which are termed as side lobes. You can make this diagram. Main lobe, side lobe.
Okay sir.
On a sloping surface, बाकी आगे आप लिख देंगे कि it returns, the side lobes begin to return the signals at a favorable angle. In that case, the transducer starts to work like this. Janus configuration eliminates this error or minimizes this effect because of its overall function.
ओके सर, मतलब बस ये बताना कि साइड लोब एक स्लोपिंग है, बस साइड लोब्स जो होते हैं वो एक फेवरेबल एंगल मिल जाता है.
दो लाइन से 3 लाइन साइड लोब एरर.
ओके सर.
हाँ, और जहां तक मुझको लगता है कि पूरा टीचर पढ़ते हुए नहीं है, साइड लोब देख लिया तो ही इज हैप्पी. साइड लोब देख लिया, वो डायग्राम देख लिया, मतलब आपने लिख दिया है कुछ न कुछ जरूर और पॉइंट पे ही लिखा है, तो दैट शुड बी ओके.
ओके सर.
Yes, it can depend on teacher to teacher. कि हो सकता है जो पेपर चेक कर रहे हैं वो थोड़ा ज्यादा देखते हो, कोई कम देखता हो, कोई सिर्फ आंख बंद करके साइन करता हो, मुझको मालूम नहीं, नॉट एक्सपेक्टिंग दैट, बट अगर आपने डायग्राम बना दिया, साइड लोब लिख दिया, तो इट इज एक्सपेक्टेड कि आपने बाकी सब ये सही लिखा है. ऑलराइट,
Yes,
एनी
sir.
क्वेश्चन, एनीवन?
सर एक चीज पूछना था.
बोलिए.
As you taught earlier that if there is a trim that doesn't make much of a difference on actual speed, it
Yes.
hardly gives a difference on the third
Indicated.
decimal place.
Indicated doesn't make
Yeah.
much of an effect on the indicated.
So which is almost equal to the actual speed.
Yes.
Only change on the third decimal place, right, sir?
Yes.
So if I try to draw understanding from this on the practical thing which we do on board ship, let's say sometime captain more speed, they try to get more trim. I mean stern. So in
Yes.
that case, it won't make much a difference.
Of course not. Now give me a situation. What is the length of your ship?
It's a 315.
315 meters. How
As
much
per
of
the
trim you
IMO,
are keeping? Difference between the
How much?
forward aft, how much you are keeping?
Not more than 2 meters.
Not maximum 2 meters.
Yes.
तो 2 मीटर्स में क्या आएगा? आपने देखा था कि 100 मीटर में 1.5 मीटर अलाउड है, तब तो 0.86 डिग्री आया था.
That's what
315
I'm
पे
saying.
का ट्रिम लेंगे तो 0.5 से भी कम का एंगल आ जाएगा.
So that's what I'm saying. So can we apply the same concept on the actual thing also, actual ship?
Yes.
If we ignore position of transducer.
पोजीशन ऑफ द ट्रांसड्यूसर से फर्क नहीं पड़ता. अगर यहाँ पे ट्रांसमिशन हो रही है और जो एंगल चेंज होगा, अगर यहाँ पे ट्रांसड्यूसर होगा तो चेंज तो एंगल वही होगा. अगर आपने इसको चेंज कर दिया है, ट्रांसड्यूसर के पोजीशन से फर्क नहीं पड़ता. यहाँ पे ये ऐसे हो जाएगा, यहाँ पे ये ऐसे हो जाएगा, सो एंगल तो वही रह जाएंगे. Position of the transducer will not make any difference because the ship is transmitting like this. यहाँ पे चेंज होगा तो ऐसा ट्रिम होगा, तो अगर आपने यहाँ पे लगा दिया तो भी वही होगा, अगर आपने यहाँ पे लगाया आफ्ट में तो भी वही होगा. सो इस केस में जो आपने एग्जांपल दिया मुझको, इफ यू वांट टू वेरीफाई दैट, you have 315 meter and 2 meters of trim. That means tan beta, that beta is equal to how much? 2 meter by 315 meters. That means beta is equal to tan inverse 2 by 315. Please tell me how much is the angle?
0.36.
0.36 degrees. Now ship is doing, let us say, actually 15 knots. So 15 knots she is doing, there will be indicated speed divided by cos 0.36 degrees. How much is going to be? Indicated speed is going to be, this is going to be 15 into cos 0.36 degrees. Is that correct or not? So बताइए कितना indicated speed हो जाएगा?
On 15. 14.99. 15.
Again. तो 0.86 डिग्रीज पे हमने लिया था तो भी 14.99 आया था. ये तो उससे और भी कम है. 0.86 डिग्री से 36 डिग्रीज हो गया, 50.5 डिग्रीज और भी कम, तो और भी कुछ नहीं फर्क पड़ने वाला.
So we can apply this concept there also, and
Yes, very much. This is for the ship only, na?
so it's a wrong myth on board.
Like what?
So it's a wrong myth. So if we have more trim, then we get speed.
No. What? No. These are two different things we are talking about. These are different things we are talking about. We are talking about Doppler log. It is reading what the ship is doing. अगर आप ट्रिम में, नॉर्मल में, इवन कील में अगर आप 14 नॉट करते हैं तो इंडिकेटेड स्पीड क्या बताएगा? 14 नॉट। अगर उसी लोडिंग कंडीशन में आप ट्रिम के साथ चलते हैं, आपको 15 नॉट मिलती है। अगर 15 नॉट एक्चुअल स्पीड मिलती है तो जरूर लीजिए ट्रिम से तेज चलती है जहाज, वो तो फिजिकल चल रहा है ना जहाज। हम इंडिकेशन की बात कर रहे हैं, उसमें गलत दिखाएगा क्या? नहीं, वहां पे 14.99 दिखाएगा। अंडरस्टूड? दिस myth is not so much of a myth which you are talking about. अगर ट्रिम से जहाज की मैनोवरेबिलिटी अच्छी होती है, आगे से रेजिस्टेंस कम होता है, भाव उठा हुआ है, पानी कम लग रहा है सामने से, अगर पानी में घुसा रहेगा तो पूरे भाव पे पानी का प्रेशर पड़ेगा, ऊपर हो गया तो थोड़ा सा कम लगेगा। सो द शिप विल सेल इजी, शी विल गेट बेटर स्पीड व्हेन ट्रिम्ड। वी आर टॉकिंग अबाउट द लॉग। ये दिखाएगा क्या? 14 पे दिखाए, अगर चल रहा है तो 14 दिखाएगा, यूं करने से 15 मिलती है, 16 मिलती है तो जरूर चलाइए 16 पे। इंडिकेशन में क्या होगा? 15.99। Understood? We are talking about the displayed speed, not the actual speed what is being done by the trim.
वही पूछ रहा हूँ सर, ये जो कॉन्सेप्ट यहाँ यूज किया, अब उसमें भी एक्चुअल स्पीड इक्वल्स टू इंडिकेट अपॉन कर रहे हैं ना हम लोग, तो फिर ट्राई टू
equal to indicate the speed by cos beta. Remember, supposing, understand this, supposing I am running and I am running at a certain speed. I don't have a meter which says how fast we are running. I am running. If I can't see what speed I am running, is it doing anything to my speed? Whatever I am running is running, correct? My actual speed is actual speed.
करेक्ट।
अब मेरे पास अगर रीडिंग आ गई, मेरे पास एक मीटर आ गया जो मेरा स्पीड बता रहा है, डज इट चेंज एनीथिंग टू माय स्पीड?
बट तो सब काम है ना सर, बताना स्पीड जो हम कर रहे हैं एक्चुअल।
तो आपका ये था, मुझको जो समझ में आया, दैट जहाज में बोलते हैं कि ट्रिम अगर होगा तो स्पीड अच्छी मिलेगी, लेकिन यहाँ पे तो बराबर मिल रही है। दिस इज व्हाट यू आर सेइंग कि 14.9 15 से 14.99 हो रहा है, यही फर्क दिखा रहा है, यही कहना था आपका? और एम आई रॉन्ग?
हाँ जी सर।
That is what I am trying to say. Your question is not addressing what we are talking here. Supposing you don't have the Doppler log. On board ship, you don't have the Doppler log. You are running even keel. आप 1 घंटे में 14 माइल करते हैं. Don't have any Doppler log. When even keel, you make 14 miles in 1 hour. And when you trim it by 2 meters, 1 meter, whatever, then you do 15 miles in 1 hour. Did you see that due to trim, your speed got increased? Actual speed got increased by 1 knot?
जी सर।
Yes. जोर से बोलिए।
हाँ जी, हाँ जी सर।
तो ट्रिम करने से स्पीड 15 मिल गई ना आपको?
हाँ जी।
अब पहले केस में जब आपके पास इवन किल पे जा रहे थे, आपका इंडिकेशन दिखाएगा 14 नॉट्स। दूसरे केस में जब ट्रिम करके चल रहे थे, जब 15 चल रहा था, दिखाएगा कितना? 14.99। इसका काम तो दिखाना है ना, आपके रिलेटिव मोशन से ये इनपुट लेके डिस्प्ले करता है ना सिर्फ। The Doppler log is not doing anything to your actual speed. Because of actual speed, it is getting some inputs and it is showing some displayed the result at what speed the ship is moving. Doppler log has got nothing to do with engine, nothing to do with lateral resistance or sailing of the ship. Doppler log is only trying to observe the relative motion and the change in the frequency. अगर आपके जहाज 14 नॉट पे चल रही है तो इतना फ्रीक्वेंसी चेंज, डिस्प्लेड स्पीड 14। अगर तेज चल रही है, ज्यादा रिलेटिव मोशन, ज्यादा फ्रीक्वेंसी शिफ्ट, ज्यादा स्पीड, ट्रिम आ गया तो एक्चुअल स्पीड जो थी उससे थोड़ा सा कम दिखाएगा, बस इतना। Doppler log is not doing anything to your actual speed. Are you confused about this again?
No, I'm not confused about the how this equipment works. I'm just asking that because the way we mathematically calculated that if these two components will be came out if it
Okay, what we are trying to say, एक बार देख लेते हैं if it addresses your it adds up to your understanding. The ship is actually doing 50 knots when even keel. जहाज even keel पे चल रहा है, actual speed is this. The log will be showing 15 knots. Why? Because this frequency shift FR etc. is given to this. The log is showing 15 knots. Actual is also 15 knots. अब चलते चलते जहाज, मान लीजिए पिचिंग हो रही है, थोड़ा सा नीचे गया, थोड़ा सा नीचे हुआ, is it going to create some kind of angle here? Rizak?
Jesus.
Okay. When this happened, what was the speed at which she was moving? The ship was moving. When this happened, what was the speed at which she was moving? 15. But because of this became alpha minus beta or not? This alpha plus beta or not?
Jesus.
That means cos alpha minus beta, cos alpha plus beta. This has changed the FR value to the log or not?
Jesus.
That means input has gone, so this will become now 14.99. The ship right now is doing what? जब थोड़ा सा नीचे गया था तो अभी चार्ज कितनी चली थी? 15। लेकिन इसके चलते इनपुट जो चेंज हुए, उसके चलते चेंज क्या हो गया?
Log speed.
So displayed speed only changing ना। अगर जहाज में कहते हैं कि लाइट शिप we get better speed, loaded ship we get little less speed, is there any problem with this understanding?
ठीक है sir.
If the ship understanding is that on even keel the speed that we get is 14 knots, but when we have a trim we generally get 15 knots, is it okay or not?
Okay sir.
Now when she is doing 14, the log will show 14. When she is doing 15 with trim, it will show 14.99, not 15. थोड़ा सा error आ जाएगा because of alpha minus beta, alpha plus beta. That's all. So that the ship is doing better speed with trim is a different aspect of navigation, more to do with physical things, the maneuverability of the ship, the effectiveness of the rudder, the lateral resistance, the front resistance, cutting the water, the bow type of the bow, etc., etc. That is to do with those. Here we are talking about an electronic equipment कि जो वो कर रहा है मैं उसके बारे में क्या बताता हूँ? The log is saying this much speed, correct or not? अगर ट्रिम होगा तो थोड़ा गलत बताएगा, नहीं ट्रिम होगा तो जो होगा वही बताएगा. So these are two different things.
Gee, sir, even practical I've seen, even after getting a little trim, I've not seen much of a difference in the speed, hardly 0.1, 0.2. So that's why I was just trying to
मुझको भी
same the
लगता
concept on that.
I agree with you. I agree with you कि मुझको भी लगता है 0.1 0.2 का फर्क पड़ता होगा. I have also not seen much of a difference in this.
Because
But-
they always say propeller should be fully immersed. That's what only condition they have.
सर आजकल
हाँ.
तो फॉरवर्ड ट्रिम से ज्यादा से उसमें फॉरवर्ड ट्रिम जाते हैं हम लोग कंटेनर वेसल्स में.
Forward trip.
यस सर, वी गो लाइक 1.5 2 meters. वो हम लोग के शिप पे प्रोग्राम है एनीरैम करके जो डायनामिक ट्रिम मेजर करता है.
हाँ.
So it says how much at this speed and this GM and all, how much at displacement, how much speed we should do, and what should be the optimum trim we should maintain by forward to get the maximum fuel efficiency.
Oh, इस तरह. I've got no idea and I really don't have any expertise on this. ये मुझको समझ में आता था, मेरे कॉमन सेंस से समझ में आता है कि हाँ अगर ट्रिम बाय स्टर्न रहेगा तो थोड़ी बेटर स्पीड मिलने की उम्मीद है. एक तो प्रोपेलर नीचे जाएगा, पानी
नहीं,
को
ये सब-
पुश कैसे कर पाएगा आगे से. हैं?
वो स्टडीज के ऊपर और एक्सपेरिमेंट्स के
अभी तो सर सब फॉरवर्ड ट्रिम चल रहा है सर, लॉन्गवर्ड जिसपे ऑल ट्रिम बाय है
हाँ सर.
कंटेनर शिप.
I am totally unqualified to comment on this. I really don't have any idea as to what kind of studies has gone into this. Not at all my point of understanding there. मैं कमेंट नहीं कर सकता इसके बारे में. हो सकता है जरूर कुछ होगा, पढ़ूंगा तो समझ में आएगा कि व्हाट इज द स्टडी, क्या कहना चाह रहे हैं लोग. पढ़ूंगा तो समझ में आएगा, लेकिन एज ऑफ नाउ आई रियली डोंट हैव एन एक्सपर्टीज टू टॉक अबाउट दैट कि फॉरवर्ड से क्यों ऐसा हो रहा है. एज ए कॉमन सेंस, कॉमन लेमैन के अंडरस्टैंडिंग से जो मेरी टेक्निकल अंडरस्टैंडिंग कहती है अबाउट थिंग्स कि हाँ अगर ट्रिम आफ्ट में होएगा, स्टर्न में होएगा तो थोड़ा बेटर स्पीड मिलना चाहिए. मेरी गट फीलिंग कहती है, मेरी अंडरस्टैंडिंग ऑफ थिंग्स कहती है, बट नो स्टडीज ऑन दिस. ऑलराइट,
Yes sir.
quickly in 5 minutes before the time is out, we are going to talk about one last topic, which is calibration of the Doppler log. Any measuring equipment must be calibrated in order to give correct result. I bought a thermometer from the shop. I place it here. After 1 minute, I see it is reading 110 degrees temperature for me. I am healthy, happy, सब कुछ ठीक ठाक, and it is reading 110 degrees Celsius or Fahrenheit. What is the problem? Do I have fever?
No sir, the equipment is faulty.
It is not calibrated, it is faulty. I ride 50 kilometers an hour speed. 1 घंटे तक 50 किलोमीटर चलता हूँ. जब मैं मेजर करता हूँ टेप से तो 55 मिलता है. Was my meter okay? Speedometer?
No.
No. So on board ship we have master, pressure and temperature meter also, which should be calibrated every year. आपने status of equipment में देखा होगा, status of certificate में देखा होगा. There is a master, temperature meter and pressure meter. जहाज में एक रेफरेंस के लिए होना चाहिए जिससे हम बाकी सबको मेजर कर सके. तो उसको शोर पे कैलिब्रेट किया जाता है एवरी ईयर. सर्टिफिकेट में जब फॉल वो नीचे जाने लगेगा, एक्सपायरी आएगी, तो हम कंपनी को बताते हैं, उसको शोर पे भेजेंगे, कैलिब्रेट करके नए सर्टिफिकेट के साथ आ जाएगा. सर्टिफिकेट हम लगा देंगे, प्रेशर एंड टेम्परेचर मीटर. Similarly, the Doppler log also is a measuring device, so it should be calibrated. So the Doppler log is calibrated in 2 steps. One is called zero calibration. Number 2 is something called scale calibration. Zero calibration is done at the jetty when the ship is stationary. With respect to ground, she is stationary. आपने Doppler log on कर दिया, आपने नहीं, technicians. Since there is no relative motion, the reading of the log should be 0. If it is not reading 0, if it is showing, let us say 0.3 or 4 or 5, there is some kind of input still coming to this FR की वैल्यू आती होगी, FT की वैल्यू, C की वैल्यू, कुछ ऐसा आता होगा जिसके चलते ये रिजल्ट आ रहा है. It should be corrected, it should be rectified so that the ship, when stationary, the log also reads 0 speed, 0 calibration done at the jetty. Next one is keel calibration, or sometimes also called measured mile calibration. Measured mile calibration. It is basically pitching the log against actual speed. So what happens, there can be a shore facility where there are two markers. The distance between them is fixed and known, let us say 1 mile. This is done at the time of sea trials. So the ship is coming here. Either we can have this or we can have a buoy also, the distance of which is measured. When the ship is coming right here, when it is abeam, the time is noted. Of course, she is moving. Time is noted. Let us say it is this. The ship is continuing to move. The log indication was saying 10.4 knots. Okay, very good, 10.4 knots. The ship is moving. When this buoy or the marker is coming abeam, we take down the time once again. We see the distance done. We see the speed. During this, the speed indication was 10.4 when the ship took how many minutes to complete 1 mile? 6 minutes.
6 minutes, 10 knots.
So is the log okay?
It is reading higher, 0.4.
It is reading higher by 0.4 because actually she was doing 10 knots. Adjustments needed. All those adjustments are done. Once it is coming within the allowable range, SDME के लिए allowed range है कि प्लस माइनस इतना में दिखाना चाहिए. अगर 10 नहीं है तो 10.1, 10 और 9.9 के बीच में कुछ दिखाना चाहिए. इतना का एरर अलाउड है. Once it is coming within that range, the two calibrations are done and the log can now be used for obtaining the ship speed by navigators like yourself. So it is now ready.
सर एक क्वेश्चन है.
हाँ जी.
लास्ट तो जो ये जीरो कैलिब्रेशन करेंगे वो डॉपलर लॉग को बॉटम ट्रैक पे रख के करेंगे.
नेचुरली अगर आप जेट्टी पे हैं तो डेप्थ कितना है?
सब 2-3 मीटर होगा.
वाटर स्पीड, वाटर ट्रैक मिलने की उम्मीद ही नहीं है. इतना स्ट्रॉन्ग सिग्नल बॉटम से आएगा कि वाटर स्पीड कुछ काम ही नहीं करेगा वहां पे.
हाँ सर, तो